Hi guys, we're ready for the next problem. Today we're going to look at Gay-Lussac's law. Let's just recap real quick what we did on the previous problem. We did Boyle's law, so you can see my crayon up here is pointing to it. Boyle's law. P1 V1 equal P2 V2. The variables P and V are side by side. We noticed that came to a indirect relationship. It was inversely proportional. So if pressure goes up, volume goes down. If pressure goes down, volume should go up. They do the opposite thing. Let's compare that to Gay-Lussac that we're looking at today. You can see the variables P1 and T1 look different. They're not side by side like they were in Boyle's law. P1 is over T1. That's a whole new look. And there are other laws that look like that too. Charles's, Avogadro. Okay, cool. There's a pattern here. Boyle's law, where it was an indirect relationship, opposite, inversely proportional. Well, Gay-Lussac, Charles, and Avogadro, they're going to be direct relationships. That's our other choice. So if, for Gay-Lussac, if pressure goes up, temperature goes up. Temperature goes up, pressure goes up. If temperature goes down, pressure goes down. Charles's law, if temperature goes up, volume goes up. So they're going to do the same thing. How do we know that? Because the variables are on top of each other. All right, cool. Before I show you how to calculate Gay-Lussac's law, let's look at the combined gas law because it's called combined for a reason. You can see I've already circled it to save some time. Boyle's law, pressure times volume. There you go. Circle in blue. Gay-Lussac that we're looking at today, pressure over temperature. There you go. And I bet you can see what the third one is. If you look at Charles's law, there it is. And we'll look at that for our next problem. All right, moving on because I don't want this video to be too long. My son gave me some Dr. Pepper. Woohoo! I took it with me to drink after I walked Emily at the park on July 3rd. When I put it in my car, the temperature of the soda was 300 kelvins, T1. Remember, we have to calculate gas laws in kelvins. All we did was take the Celsius temperature and add 273. So there you go. We're already in kelvins, so we can plug that 300 into our formula and calculate. We don't have to do that. The conversions have already been done. The gas inside the can was under 3 atmosphere of pressure. That's our P1. It was so hot that day. Unfortunately, I left the Dr. Pepper in my car. The temperature of the soda rose to 400 degrees kelvins. That's my T2. We've already established that this is directly proportional and a direct relationship, meaning if our temperature went up, we already know that our P2 should go up. Direct relationship means that these variables are going to do the same thing. So my temperature rose to 400 degrees kelvins. What is the new pressure? That's going to be my X. Okay, sorry. Things popping up. Let's get back to it. And P2 is going to be my X. Cool. Was 300, now 400. All right, let's do it. I like to set up my parentheses before I plug and chug, especially when I'm first learning something, because it gives you a real quick, check yourself to make sure that you set it up right, and so my parentheses do look like my variables over here. I feel pretty good. P1 was 3 atmospheres, T1, 300 kelvins. P2 is my X, that's what I'm solving for, and temperature rose to 400 kelvins. We've already established since temperature went up, I know that my pressure should be higher than 3. It's also directly proportional, so since it went up from 300 to 400, didn't quite go up half as much again, then I know that my P2 is going to go up, but not quite half again. So if 3 went up half as much again, right? Half of 3 is 1.5. 3 plus 1.5. If it went up exactly half again as much, my X would equal 4.5. Well, it didn't go up half again as much. It's slightly under. So I know it's going to be slightly under 4.5. And it's good to kind of think through those things. Think through the relationship first. Because then once you get that answer, you're very confident that you got the right answer. Okay, here's how I teach it. I go, hey kids, where's the X? And they're like, right there, Ms. J. Cool. Draw a backwards fish. So from my X, I'm going to draw a backwards fish. And this is how I know where to start in my calculations. I'm literally just going to retrace that fish. When I get to the X, I'm going to hit equal or enter. All right, here's what we're going to do. We know where we're going to start. We're going to start at the 400. And the first thing we're going to do as we retrace our fish is multiply. So here we go. 400 times, just retrace the fish, 3. Okay, 400 times 3. And if I retrace my fish here, the next number I get to is 300. The next order of operation is divide. Okay, divide by 300. Retrace your fish, and that's where you're going to hit equal. Now, a lot of you were thinking, I didn't even need that because it's just cross multiply. Okay, yeah, if you can look at that and go, yeah, I just cross multiply, do that. Okay, this is for the kids that didn't learn that skill, and that's okay. We're going to get the same answer. You put it into the calculator, and you're going to get 4 atmosphere. And according to our predictions already, we know that that's right. I hope that helped. I'm going to end now to make it short and sweet. If you need further help, contact your teacher. Love you. Bye.